Okay, thank you everyone. So as Amber was saying, we're going to talk about defending at scale with the help of Osquery and the MITRE ATT&CK framework, but by using breach reports to see what should we actually be doing that we're perhaps not doing instead of just trying to implement everything at once. So my name is Guillaume. As Amber introduced me, I'm a product manager at Uptycs. However, I'm a blue team kind of guy. I've been building blue teams, doing security architecture in a lot of companies. So even though I know our keynote this morning said that product managers would be the least paranoid people in a company, I think it doesn't work out for me. And as my accent might have tipped you, I come from where milk comes in bags, which is Canada. For those of you who didn't know, that's an actual fact. So yeah, I know it's weird. Hopefully the banning of plastic will get rid of that. So in this talk, we're going to talk about defending at scale and the issues we have with that. So for those of you that have any kind of environment with thousands of machines, tens of thousands of machines or more, first of all, there's a lot of best practices that, like, they're best practices with air quotes because everyone's been doing the same thing just because we do it. And obviously it's not working out that well because people get breached all the time and most of them were doing best practices. And there's just too much noise when we're monitoring because we're monitoring for a bunch of different things that is not necessarily that critical, even though we've been led to believe it is. So alert fatigue leads to people hating their jobs as a security analyst, which makes them less effective, and then everything is terrible. So what I like about the MITRE ATT&CK framework is that it's based in reality, but we can also use it to review actual attacks because we've been getting more and more public reports so we can really see like how realistic were these attacks and how does that work with MITRE. And then the next step is how do you use Osquery to defend your environments or to detect these attacks with Osquery. So I started looking at a few different attacks last year to see what kind of information we can get. So I'm not going to talk about the marketing reports where it's like APT this, APT that, without the technical details, but there were a few really good ones with a lot of details. So I picked 3 of them and went through them and ended up using really 2 of them. So SingHealth, for those who aren't familiar with it, is a healthcare organization in Singapore. They were breached. A lot of medical records stolen, pretty much millions of people, a big portion of the population, but politicians were also targeted specifically. So that's a really interesting breach. And the report is very, very detailed and reads like a novel. Then I was thinking about the Equifax breach, but the report on that, I don't know if anyone here has read it, but I guess it's great if you need to get to sleep because it talks about problematic IT management and all that, but it's not very technical. So for my purpose, not great. But then there's NotPetya. Maersk is one of the companies that got breached by NotPetya, and while there's no public report, they've actually been pretty upfront and communicated a lot of stuff. And in the book Sandworm that was referred in a previous presentation, there's a lot of detail there. And as someone who lived through a NotPetya incident, from what I read there, it seems to be very credible, and even though it's not an official report. So I thought that would be a good one to use. So if you want to get the reports, I got some shortened links there. It was not malware at the time I made the slides. That's not a guarantee if you're the insurance company. So I'll give you a few seconds. So that's the full report. Then we have a great article, which as I was working on this, I found out that Matt, not Max, wrote a pretty good article on mapping a bunch of the SingHealth attack to the attack framework. And then this is a specific article about NotPetya that Wired has, but also I'm going to be using some of the reports by incident response companies like CrowdStrike, for example. So if we start with SingHealth, this is an environment that's pretty large, and the breach is, like a lot of breaches, required first breaching a workstation. So they broke into a workstation in August 2017. And then around December, they did lateral movement to get to a second workstation. But when they did incident response, the first workstation was long gone, right? Like it had been reassigned to someone else because they found out about that breach a while later. So they could never really get that first workstation to know what the initial delivery mechanism was. So there's a few theories, which we'll talk about, and we'll see how Osquery can help us with that. Then there was lateral movement. The lateral movement then led to them being able to connect to Citrix servers. from Citrix servers, enumerate credentials, whatever, connect to the medical database, run big queries, grab all the data, and exfiltrate it. So it's a pretty typical type of breach. But one thing I like to highlight when I show this is one thing that we hear a lot of security people say is the attacker only needs to be right once or to succeed once, and defense needs to succeed all the time and never fail. It's usually not true unless you're talking about like a publicly exposed database with SQL injection. Most of these attacks have multiple steps. So if we're using different tools, including Osquery, and here we could have detected the initial infection of workstation 1, the lateral movement. There's many places where we could have turned this into a minor incident instead of a breach. And keep in mind, I'm using this as an example. I'm not saying that they should have done X, which would have prevented the breach, because it's really easy to say that. However, if the attackers are really persistent, maybe it would have slowed it down and they would have done something else. So the initial entry, as I was saying, was 2 workstations. The second one made callbacks to command and control in August 2017. So if we look at the callbacks, there's a few different MITRE tactics that were used in there. So specifically, we had PowerShell. We had probably user execution. Keep in mind that first machine is gone, so we're not 100% sure how that happened on that machine. And then the malware that they found on the second one had remnants of a public rat. There's no more details in the report, but I take that to mean that they were probably using some underground commercially available kit that had password dumping capability. So when I read that, I think something like Mimikatz that's going to dump Windows credentials. And it's possible that that was delivered using spear phishing or just a malicious attachment. I found that to be weird because for those of you that do incident response, usually if it really comes in via email, you usually find that email unless it was sent to like someone's webmail or something like that. But it could also be the ruler exploit. So is anyone here tasked with securing Microsoft Exchange environments? All right, good for you. Everyone switched to Office 365 and Gmail. So the ruler exploit is a way that you could create a rule in Outlook or the Outlook Web Access that would eventually launch code on the workstation of the person running the fat Outlook client. So if I steal someone's account on Outlook, I go create a rule, and when they open Outlook on their machine, it's going to execute whatever command I wanted. So that's been patched, but it requires some configuration. So looking at that, I'm just looking at all these different MITRE tactics, and I think with socket events and process open sockets, if we run that against threat intel feeds, we have a good chance of detecting some of the low-end attackers. I think in the case of SingHealth, it was really targeted, so I don't think that would have been enough. However, PowerShell logging with Osquery is really, really easy. So that's one thing we're going to look at. Then monitoring processes and their parents is also something that's really easy with Osquery that we can do on large environments with great success and few false positives. And then the whole office, was it ruler or something else? Well, it's really hard to harden Office in very large environments because of the way that you've got like Word, Excel, PowerPoint, and if you've got 100,000 users. But with the way Osquery uses wildcards and everything, it's actually possible. So the first one, start from process open sockets, easy. But I like to take specific attention to ports 445, especially in large Windows environment, especially when the source and destination are either in the same subnet or between subnets of different workstations, right? Because my machine connecting to a file server using 445 sounds pretty normal, but my machine connecting to my coworker's machine on 445, well, that should be blocked, but if it's not, and sometimes you just can't block it, then you definitely want to detect that with Osquery. And that's also something that I find that like in the large environments I worked in, we usually have like 16 business units using 14 different types of host-based firewalls, right? So instead of assuming that the configurations were right by deploying Osquery, we just monitored, and when we saw 445 indicating lateral movement, I know that, oh yeah, the guys in this business unit using semantic firewall probably didn't configure it properly, right? So instead of checking every config, Windows is noisy enough. Like I know if people can't connect, they'll eventually do it by just going to my network places. So that's a great way to confirm your controls are right. Then for the PowerShell, you need to enable script block logging. And I think that in large environments with a lot of workstations, very few people want to centralize all the logs from all the workstations to a single place, right? So I'm sure some SIEM vendors love that because that's probably really expensive to do. But if you're using Osquery, there's a few things that are interesting. So first of all, like the length of the commands is a really interesting one. So I can't really remember which talk was on or off the record, so I'm not going to mention any names because it's a little bit confused in my mind already, but someone mentioned looking at the length of SSH commands. It's the same thing with PowerShell events. You can see outliers really, really quickly. And just by logging the size of all that to a central environment and logging the script block logging to a central environment, it's much lighter than grabbing the entirety of Windows events from a single machine. But I like to run queries for specific obvious bad words. Of course, in a targeted attack, you won't catch any APT using like straight up Mimikatz. You probably will catch some pen testers that don't have a whole lot of time. They don't care about not being noisy. But I've seen cases where people do make a mistake, right? Like they try the easy way, and then that's a good way to detect them. But then also to look for specific methods used by the PowerShell scripts that are being executed. So invoke shellcode, for example, is something that when people are using PowerSploit, for example, you'll see that, or privileges being elevated with PowerShell. So these are all things that if you can monitor that across your entire environment and look for outliers, you have a good chance of detecting some weird behavior using PowerShell. And the script block count trends, wow, that was hard, is one of the most useful ones. So you'll see that a lot of that malware will encode a lot of data in a single PowerShell command. So you'll see an explosion. And of course, the first time you start doing that across a big environment, you'll see that there's other tools that do something like that. You probably need to know that these are known good long scripts. I'm thinking tools like Chef or Puppet, like these kinds of deployment tools, if you're using PowerShell, yeah, they might have a behavior that's similar to that malware. So just be aware of that when you turn that on and you start looking at that. But then if it was the ruler exploit, that means that Outlook was executed and then ran something else, right? So because processes and process events have the PID and the PID of the parent, it's really easy to see what was the parent of what. So we have a small Python script on the Uptycs website, but it's actually really easy to do this with an SQL query in Osquery. It's pretty long, so not really readable. Might also be a good query to test for performance, as Zach was talking about before. But you really want to look for weirdness. So you can't just look for obvious bad things, but we can look for things that are completely out of the ordinary. So manually, we started by doing, okay, we'll select for processes, for example. So if you have services.exe that's running, all right, on Windows, it's PID 568, and its parent is 476. So that's what we want to do in a single query. What is 476? That's WinInit, which is totally expected. And the PID of WinInit is 400. So then you can go all the way. But on Windows, Mac, and Linux, there's a lot of obvious bad parent-to-child relationships. Wow, that really sounded weird. So for example, if you have Edge all of a sudden running cmd.exe, you probably never want that. Same thing for Microsoft Word, all the Office document, like PDF readers and all of that stuff. So what you want to do is make sure that on all these environments, you don't necessarily have to look for every parent and child and do complicated anomaly detection. You can just go and look at, for example, whenever services is running and the parent of services is not winInit.exe. So you'll catch like anything that's trying to pretend to be services.exe. And I just want to give a shout out to Filippo Mattini. He's got a bunch of these queries on GitHub where he's been documenting a bunch of stuff. So if you want more examples, he's got a whole lot there if you want to get started on the Windows side. So we're going to talk a little bit more about Windows. Who here, show of hands, runs Windows, Osquery on Windows? All right, it's catching in popularity, which is nice. So I don't think the text at the bottom is going to be super readable, but we talked about the Office hardening, right? And there's a lot of like configuration management tools that big enterprise have to track configs and all that. People push things with GPOs, and sometimes it's really complicated to keep track of what's actually happening on the machine. And again, because Office is configured per user and per app, you can't just check like one specific registry setting to say that macros on files downloaded from the internet are going to be blocked, for example. You need to check that for every user in every Office app that happens. But because Osquery is able to do wildcards and multiple wildcards in this case, you can look at the registry and grab HKey users /person sign. So it's going to iterate through all the different users that are on a machine and then do the same thing after that version number. So you do it for Word, Excel, PowerPoint, and all of that. So that sounds like a stupid, like easy thing, right? Like you just have a few wildcards. But having tried to implement things like that with enterprise security configuration management tools, it is more complicated in many of them than what you can do with a simple SQL query. So in this case, you want to look for all these different things, and that's going to tell you what the SID of the user is and if that setting is compliant or not. So then you can cover those tactics T1192 and 1193. Now, because it's Windows, there's backslashes everywhere, right? And so because there's backslashes everywhere, you can use string operations. So this is something I really like doing, especially on Windows. I like using string operations on the registry to split where there's a backslash. So in this case, we know that in the registry, you go HKey users, /, and then there's a SID. That SID can actually resolve to a username with the users table. So if you just split that, then you can get the output in a very clean way. So in this case, I had a user called G that had the setting set to 1, and then I have my SID right there. So by using string operations, then you can just log the very valuable part of data without grabbing like the entire thing and having to work with it later. So in this case, it's telling me that on this machine, the user G has block content execution from the internet set to 1, which means that I know that like a macro won't be executed on it. Now, the next step is you want to do that for every single one of these sub-applications. Then for Ruler specifically, Microsoft has a setting called Enable Unsafe Client Mail Rules. So from the name of it, it sounds like something that should not be equal to 1. So you definitely want to be checking that because it disables the patch. It just completely, it's like, hey, you installed this patch, great, now just turn it off. And you need to check version number. So again, it's all stuff that we can do really easily with Osquery. If you have it running already, it's just a few more queries. And with a lot of other commercial tools, it's hard to put everything together. Then we had the lateral movement and privilege escalation. So it's the same thing. Like it happened over 6 months, right? So there's a lot of opportunity for detection. The malware was spread using Windows shares, weak local admin credentials, and credentials stored in clear text, and then using Citrix connections in remote desktop. Then the person tried to connect to a database, failed multiple times because they had an account without the right privileges. They finally exploited an app to get a service account, and that's when they broke in. So all that lateral movement, we talked about it before, we can monitor with socket events, all that lateral movement really easily. On Windows, we mentioned 445. Obviously, remote desktop is a pretty common vector, and on Mac, most people don't have enabled remote desktop sharing VNC type of stuff by default, at least, so it's less common. Same for SSH, but you want to be looking at that. So the one thing I found that was the most useful in large Windows environments is ensuring that service accounts or accounts in general don't log in the wrong way. And what I mean by that, so I'll just go over my example before. I said you look at port 445. You can have a list of known subnets that can connect to port 445, like management systems. That's fine. That's pretty straightforward. You would make that query as long as you needed to with all the different trusted sources. But then why do you need to make sure accounts log in the right way? And what do I mean by that? I mean, a person should log in interactively, and a service account should log in as a service, never the other way around, right? So one of the local admin accounts that was stolen had the password p@ssw0rd, which is a great password because it fulfills most password complexity policies, right? So it's hard to know, did someone steal hashes or did they simply succeed at the first attempt, right? So they don't really know. But it was an account that hadn't been used for over 180 days. So the first thing I'd like to do on these Windows environments is be sure that if LAPS is deployed, so LAPS is a tool for automatically changing those passwords, you can query that it's configured properly with Osquery and track that across your entire environment, again, just using that registry table. So you can check, is it really setting a password that's going to be longer than 31 character, right? So you want to check that the key exists and then check the length of the character. So that's one thing. For a lot of these examples, I'm showing the query for knowing that the value is right, but keep in mind that on Windows, if there's no registry key, it's going to revert to the defaults, right? So if you have thousands of machines, for sure some of them are misconfigured, make sure you check for the existence of the key and then that you check for the proper value. And once they had that stolen account with the weak password, we're not sure where they took it, but it's a local admin password, right? So as soon as one machine is compromised, you got to assume someone's going to have it, even if it was a more complex password. So they started connecting to Citrix servers where they shouldn't have been able to connect. And at some point, they say Joanne connected to and realized there was a live session by an admin account connected on a Citrix server via RDP from a virtual machine. And that was the type of access they didn't think system administrators had, but obviously they did because they were logged in. So that kind of tipped them off that something might be wrong. So a great way to track that kind of activity using Osquery is using the logon sessions. For those of you that have a naming convention for their accounts. So I know a lot of people have like different ways to name accounts that are regular accounts, admin accounts, but service accounts specifically. We have a table that tells us username, what domain the user is coming from, and their UPN as well. So in this case, what you want to do is actually look at the logon type column that's in that table. So the logon type will tell you if a login is interactive or not. And so if you're just trying to monitor thousands of machines and not get too many false positives, the first thing you want to do is look for all the accounts that have the naming convention of a service account that are logged in as interactive, right? So if you have a logon where the name is like SVC underscore, if that's your naming convention, and the logon type is interactive. So that's the first thing. You'll catch a lot of like misconfigured application. You know, like everyone has like that one server-side app that's not a service that someone needs to, usually it's like an old legacy thing. So you'll catch a few of these, then add these to your queries, and what you'll find with this is going to be really high value. Usually could be malicious, or it can be like a sysadmin who has access to that service account that's trying to troubleshoot something which maybe they shouldn't do with that type of account. Then you just do the opposite, right? So if the login type is not interactive and the name is not like SVC or it's like ADM or something like that. So as you can see, like we've just gone through maybe like 8 or 9 different tactics from MITRE ATT&CK, and it gives us a common taxonomy to discuss them, and we can map that to our Osquery techniques. And I guarantee you most of the stuff in there, even though there's only 10 of them, is more valuable than a lot of the, like all the hardening stuff that we do, right? Like we take, okay, CIS benchmarks for Windows, it's that thick, but there's probably 20 settings that are very valuable for everyone, and the rest is like, yeah, sure, if you're the DoD, you want to disable Bluetooth, that's probably a really good idea. Probably doesn't matter as much for a lot of the other companies. So that's why I like using ATT&CK for that. And so if we look at NotPetya, so the title is The Untold Story of NotPetya. I found that to be kind of an ironic title because you just told it, so not technically untold anymore. So for those of you that aren't aware, in 2017, NotPetya spread. Was it collateral damage or not? I guess we'll never know. But essentially, a Ukrainian tax software update server was compromised. That was the initial infection. Then it started spreading, and there's been a lot of misconception about how NotPetya spread. A lot of people were saying, oh, it's Eternal Blue, blame the NSA. It did use Eternal Blue as a last resort, but it did a lot of things before that we could detect, right? So it would enumerate nodes, do UNC copies. You know, we talked about the shares and the lateral movement. And the interesting thing it did was it would track the privileges it has, and it would track what AV is installed. So it's just using like pretty dumb matching with specific hashes, right? Like, is it running this hash, which is Symantec version whatever? If so, don't start encrypting because that's how Symantec will detect me. So I'll try to spread more even though I won't encrypt this machine, all that. Then it would encrypt the some files, put some malware in the master boot record, create a scheduled task to reboot. And then when people rebooted, they got the screen telling them to, you know, just Bitcoin me some Bitcoins over and we'll decrypt your data, even though the email address that was on the message was not a real email address, so it was definitely not real malware. So all the steps that are in there, if you just go to the MITRE website, they're already all documented. It goes from credential dumping to the data being encrypted, which is something you could easily detect with file events in Osquery, for example. So all of these different things, they're really, really good ways of getting started with the Osquery configuration without just creating thousands of queries for no reason. So I'm getting flashed a red sign. I guess that means I'm almost done, right? So you want to track large amount of file activity for ransomware, for example. So T1085, T1077, 1047. You want to track the processes for suspicious commands and consider using honey users. I don't know if people are going to want to answer this. Who runs honeypots in production? Yeah, OK, no one wants to say. But consider running honey users in conjunction with Osquery. So what I mean by that is inject some accounts that have almost no privileges in your endpoints, and then track to see if they're ever used in the process events. So NotPetya, for example, when it's spread laterally, it would run a command either using psexec or wmic, but it would carry over the password for everything it managed to get already, right? So every time it would hop from one machine to another, it would include all the other passwords. So why don't you have like a honey user, no privileges, but just look for its password in your Osquery logs. And so because of that, because of MITRE being an open taxonomy for all of this data and Osquery being a way that we can analyze that on every operating system, I think it's unbeatable. Like we can develop these queries really, really fast. It's much easier to use than a lot of the commercial software out there when you want to go and make your own configuration. And I want to say, like, if you work in a blue team, read those incident reports, because even though some of them are kind of light on details, every year there's like 2 or 3 of them that are very realistic and will tell you how you're likely to get breached, and you can use that to be sure your Osquery configuration is actually as effective as you think it will be. And I want to give a shout out. So T.O. Seller is Filippo. I mentioned him before. But there's also Eric, who is starting up a query hub on the Osquery repo. So that's on the official Osquery repo. And you can go there, and if you have any queries, for example, you start mapping queries to the MITRE attack framework, that would be a great place where to contribute them. And at Uptycs, we're working on a bunch of MITRE attack stuff in the next few months that we're pretty excited about. All right, well, thank you very much.